Microsonic Plasma Energy Device Feasibility Studies with Circuit Analysis, presented by Man-Tim Lee, date April 2023. Introduction. My name is Man-Tim Lee. I am 70 years old living in Singapore. I am a retired engineer experienced in electromechanical repair and maintenance of steam sterilization equipment in hospitals. I wish to share with the knowledge seekers that I did a feasibility study on the Microsonic Energy Device, MSED, inspired by Mr. Maxwell Chikumbusel, to add on to the knowledge to extend my understanding of how to synthesize these with known circuits, and to enhance with the cache plasma technology for continued research. Microsonic Energy Device. The Microsonic Energy Device MSED was presented by Mr. Maxwell Chikumbusel per his video. Source: Maxwell Chikumbusel presents small 500-watt MSED free energy device, YouTube, by Thomas Mesa. The device could power a television set by microsonic energy in radio frequencies from the atmospheric Earth environment and converted the radiant energy into electricity at 500 watts in one electronic circuit board. Microsonic RF from Earth. On the internet, I found a video about low frequencies receivable on the ground by radio astronomy. Source: Low Frequency Universe, MIT, YouTube, by MIT Film and Video Production Club. In this video, Dr. Mary Kapp presented a chart showing atmospheric opacity intensity versus wavelength, in which there is a window of zero opacity between wavelengths 5 cm to 10 meter. This I may understand it as radio astronomers observe on the ground in full transparency in these frequencies, as f times lambda equal to c, the velocity of light, since RF is light. F equal to c divided by lambda equal to 2.997 times 10 to the power 8 meter per second times 1 over lambda. For lambda equal to 5 cm equal to 5 times 10 to the power minus 2, F equal to 2.997 times 10 to the power 8 meter per second times 1 over 5 times 10 to the power minus 2 meter equal to 0.5997 times 10 to the power 10 per second equal to 5.997 gigahertz. For lambda equal to 10 meter, F equal to 2.997 times 10 to the power 8 times 1 over 10 equal to 29.997 times 10 to the power 6 per second equal to 29.997 megahertz. Radio frequencies between 30 megahertz to 6 gigahertz is VHF, very high frequency, or to UHF, ultra high frequency, and SHF, super high frequency bandwidths, as used in television transmission. I may be interested in lambda equal to 5 cm 6 gigahertz because this wavelength can be received with a very small size antenna area, such as a heatsink used in desktop computer CPU cooler. Dr. Mary Cap also presented in her video the sound of planet Earth, which peaked at 9.5 kHz. I may understand that sound waves between 0 Hz to 20 kHz are audible frequencies. When the velocity of propagation is at the sonic speed 1125 feet per second or 343 meters per second, it is audible sound. Source: Wikipedia. In RF radio frequencies, the velocity of propagation would be at the speed of light, c equal to 2.997 times 10 to the power 8 meters per second. The sound of Earth peaked at 9.5 kHz is coincide with our audio frequencies, yet in speed of light c. For 9.5 kHz, lambda equal to 2.997 times 10 to the power 8 divided by 9.5 times 10 to the power third equal to 0.3155 times 10 to the power 5 equal to 31.55 kilometer. Also, lambda equal to 343 divided by 9.5 times 10 to the power third equal to 0.0361 meter equal to 3.61 cm at the speed of sound. This frequency at 9.5 kHz is somewhere less than halfway of the audio frequency bandwidth, 20 kHz. This may be the basis for microsonic energy, E equal to h nu equal to 6.6256 times 10 to the power 34 times 9.5 times 10 to the power third equal to 6.2943 times 10 to the power minus 30 Newton meter. This photon energy may be small, yet in one heat sink there may be 36 grams, that is 10% of 360 grams of the heat sink weight, are of nano-coated aluminum oxide, 12 free electrons. Atomic weight equal to 101.96 grams aluminum oxide, and also the antenna may be able to energize 36 divided by 101.96 times 6.2 times 10 to the power 23rd equal to 2.126 times 10 to the power 23rd molecules of aluminum oxide equal to 12 times 2.126 times 10 to the power 23rd electrons, equivalent to 25.512 times 23 electrons, divided by 1.6021 times 10 to the power minus 90 Newton meter per electron, equal to 15.9241 times 10 to the power 42 Newton meter, equivalent to 15.9241 times 10 to the power 42 divided by 6.2943 times 10 to the power minus 30 equal to 2.5299 times 10 to the power 72 microsonic photons. This is the antenna reception capacity. Energy to move an electron is 1 eV equal to 1.6021 times 10 to the power minus 19 Newton meter. This microsonic energy may also include its zero-point energies, E0 equal to n plus half times h nu, where n equal to 0, 1, 2, as in the Planck's second quantum theory. Antenna circuit. The antenna circuit was presented by Mr. Fred Faisal in his video. Source: Plasma Frontier, Deeper Understanding, 11 February 2017, YouTube. After a modification, this circuit may be tuned to receive the microsonic energy to convert into 12-volt DC. In my study, I have come across a 1N4001 diode, 1 ampere, 35 volt. This diode has a forward voltage, Vf equal to 1 volt, which means when there is a current flow across the diode, there would be 1 volt DC across the diode. The 35 volt specification is the reverse bias voltage that the diode can take without damage. I wish the circuit to acquire 6 volt on the anode, positive electrode, so I need to use 6 pieces, 1N4001 diode. Likewise, 6 pieces for the cathode, negative electrode, 12 pieces to make 12 volt DC. Quantity: 12, part number 1N4001. Description: diode, 1 ampere, 1 volt, 35 volt. Manufacturer: Diodes Incorporated. Source: alldatasheet.com. When the antenna receives an RF, the small wavelengths 3.61 cm to 5 cm may fall onto the CPU heatsink antenna, the vibration being trapped between the flaps of the heatsink. The photon energy, E equal to hV, shall be absorbed by the nano-coated aluminum oxide, Al2O3, and by the nano-copper oxide, CuO, at the base of the heatsink antenna. Positive vibration may deposit positive charge to the capacitor C1 anode. A negative vibration may deposit negative charges to C2 cathode. Charging C1 shall push a current through from its cathode through halfway the D2 3 times N14001. C3 may have 6 volt. Discharging C1 shall draw a current to its cathode through D1 3 times 1N4001. C1 may have 3 volt DC. Antenna tuning. The supply of electrons are from the chassis ground G. The Earth is an electron reservoir. RF is an alternating current AC. As I wish to tune in to the 9.5 kHz, and my objective is to have V equal to 12 volt DC, C1 would have to have 3 volt DC. The rectifier diodes 1N4001 has 1 ampere capacity, so I may expect to draw 1 ampere from it. To tune C1 into 9.5 kHz, therefore I set Xc equal to 3 volt divided by 1 ampere equal to 3 ohm, as seen by C1. Xc is an AC reactance at 9.5 kHz equal to 1 over 2 pi Fc. That is 2 pi times 9.5 times 10 to the power third times C equal to 1 over Xc equal to 1 over 3 mole. That is C equal to 1 over 3 divided by 2 pi divided by 9.5 times 10 to the power third. C equal to 5.5844 times 10 to the power 6 equal to 5.6 μF. That is C1 equal to C2 equal to 5.6 microfarad, 3 volts. On the internet, I found this capacitor applicable. Quantity 2. Part number 8601606720006. Description: capacitor 5.6 microfarad, 50 volt. Manufacturer: Vishate. Source: www.dgkey.com. The 50 volt is the surge voltage of the capacitor that I could find. As I only need 3 volts, this may mean that the capacitor shall not get fully charged, and the voltage across the capacitor may be clipped by the diode to about 3 volt DC each across C1 and C2. Up to this point, the power available from the diode are 1 ampere and voltage at 12 volt DC, and the antenna circuit may have power at 12 times 1 equal to 12 watts. I checked on the internet that a recent model of OLED 83 inches TV set has electrical utility label at 327 kilowatt-hour per annum. This means the television set shall have consumption at 327 kilowatt-hours every 365 days, equal to 327 times 1000 watt-hour divided by 365 equal to 895.8904 watt-hours every day, equal to 895.8904 watt-hour divided by 24 hour divided by 3600 seconds equal to 0.0104 watt per second. For short, we can take 0.327 watt as the operating consumption. In the television specifications, it indicated that the power required at standby was under 0.5 watt. These specifications indicated that the antenna circuit may be applicable to power the television set. My next question is how to convert the 12 volt DC to 230 volt AC 50 Hz to power the television set. "12 volt DC to 230 volt AC inverter." In my previous video presentation, I presented the Alex Chekakov demagnetizer circuit, YouTube. David Perry's Spacewalk Drive, Feasibility Studies, YouTube, by Mantim Lee. Transistor KT815A has IC maximum equal to 1.5 ampere, is too high for the diode 1N4001 equal to 1 ampere. By changing Q1 and Q2, the NPN transistors, into 2N2218, the IC max equal to 1 ampere, for which the transition frequency Ft equal to 250 MHz. I may get the 12 volt into AC at 250 MHz. The working principle of this demagnetizer circuit is as below. The circuit has not a capacitor in the primary coil for the transistor to oscillate. This circuit shall oscillate in its transistor's natural frequency, as according to the transistor specifications, Ft is transition frequency. 2N2218 Ft equal to 250 MHz. This is in the VHF bandwidth. As per synethize specifications, Z1 equal to VDZ 6.2B, 6 volt DC, limit. IC equal to 5 milliampere. 51K variable resistor, trim pot, setting at 37.4 kilo ohm. This sets the Q1 base to 37.4K divided by 51K times 6 volt equal to 4.4 volt DC. This voltage Q1 is on. Current flow out from the emitter into T2 transformer center tap, which induce a positive voltage, a forward bias for Q2 equal to on. Q2 collector current draws in, reverse the current flow in T2 center tap, and stop the current to the 1K resistor on Q2 base equal to 0 volt. Q2 is off. Once Q2 is off, the current in T2 primary flows through the 1K resistor again, which induces a positive voltage to Q1 emitter. Q1 equal to off. Reverse current sets Q2 bias to negative. Q2 equal to off. And the process repeats. Q1 equal to on. Q2 equal to on. Q1 equal to off. Q2 equal to off. The circuit in continuous oscillation. When transistor Q1 is on, the collector to emitter has a voltage drop of VCE set equal to 1.6 volt, the 2N2218 specification. The input voltage to the transmitter T2, 12 volt minus 1.6 volt equal to 10.4 volt. The VCE set equal to 1.6 volt. The primary winding N1 is 5 turns, AWG14, 1.63 mm, capacity 8.3 ampere. The primary coil is thick wire to stay in shape with the center tap at 2.5 turns. It is like a wire. It has no resistance, no voltage drop. So 10.4 volt sets a forward bias at the base of Q2 equal to on. Once Q2 conducts, IC equal to IC set equal to 0.5 ampere, and the collector VCE set equal to 1.6 volt. All the current at the Q2 will drain via the Q2 emitter. This shall stop the branch current to the 1K resistor. Q2 base becomes 0 volt, shall turn the Q2 VBE equal to 0 volt. Q2 equal to off. When Q2 equal to on, the voltage at the center tap equal to VCE set equal to 1.6 volt sets the emitter of Q1 equal to 1.6 volt. The Q1 bias voltage becomes 2.6 minus 1.6 volt equal to 1 volt. The VBE set equal to 2.6 volt. is inadequate to forward bias equal to reverse bias, it shall set the Q1 equal to off. Once Q1 is off, its emitter equal to 0 volt. The Zener dial is fixed at 6 volt, setting 36.4K divided by 51K times 6 volt equal to 4.4 volt DC, and so it keeps Q1 to on, turns on again. The sequence goes on: Q1 equal to on, Q2 equal to on, Q2 equal to off, Q1 equal to off, Q1 equal to off, Q1 equal to on, resulting Q1 equal to on off, and Q2 equal to on off, continuously making current flow in transformer T2. The primary coil frequency equal to transistor natural frequency, Ft, equal to 250 MHz in the VHF range. We now calculate T2 N2. The secondary can be wound with diameter wire size AWG20 equal to 0.61 mm, 2 ampere capacity. N2 equal to 2.5 times 230 divided by 10.4 equal to 55 turns. VCC minus VCE set equal to 12 minus 1.6 equal to 10.4 volt. ICE set equal to 500 milliamp equal to 0.5 ampere. VA equal to 10.4 times 0.5 equal to 5.2 VA. The secondary equal to 5.2 VA divided by 230 volt equal to 0.0226 ampere. T2 output equal to 230 times 0.0226 ampere equal to 5.2 watt at 250 MHz. To tune in with the 0.5 ampere demand from Q1, Q2, we may set XC3 equal to 12 volt divided by 0.5 ampere equal to 24 ohm. That is XC3 equal to 1 over 24 mile. That is 2 pi times 250 times 10 to the power 6 C equal to 0.417 mile. C equal to 265.5 picofarad. That is C3 equal to C4 equal to 265.5 picofarad. The closest I could find on the internet was 27 μF, 6.3 volt. On the internet, I found this capacitor applicable. Quantity 2, part number UUD0 J270 MCL 1GSC. Description: capacitor aluminum, 27 μF, 6.3 volt. Manufacturer: Nichicon. Source: www.djkey.com. Note: 265.5 picofarad equal to 0.0003 μF, mostly available in 100 volt. So I take the 27 μF 6.3 volt for C3 and C4, as stabilizing the power supply at 12 volt is more important than tuning the capacitors to 250 MHz. Low-pass filter. The output of the transformer T2 is AC at 250 MHz. The local electricity appliances uses 50 Hz. We may solve this problem by using an inductor to capacitor circuit, the LC low-pass filter, which shall allow the lower frequency, 50 Hz, to pass through at the output. For the inductor part, I may apply the Cache plasma technology, uses the Cache McGrath coil, copper oxide nano-coated for this filter. The McGrath coil is equivalent to total inductance Lt equal to 0.8290 microhenry. Details calculated presented in my previous video. Source: YouTube. Cache Home Power Unit AC Circuit Analysis. YouTube by Mantim Lee. At 250 MHz, Xt equal to J times 2 pi times 250 times 10 to the power 6 times 0.8290 times 10 to the power minus 6 equal to J times 1320 ohms. Apply the Kirchhoff law to low-pass filter circuit. We have Vi 250 meg equal to 230 volt. Loop 1. 230 equal to I1 times J 1320 plus I1 minus I2 times minus J XC, equation 2. Loop 2. 0 equal to I2 minus I1 times minus J XC plus VO50, equation 3. We have two simultaneous equations, have three unknowns, I1, I2, XC. It cannot be solved. I shall use another method to find out XC, then analyze this further. The low-pass filter may be modeled as a voltage divider circuit. From this model, we have Vout equal to Vi times Xc divided by Xt plus Xc. For an ideal filter, we would want Vout to be very close to Vi. Hence, I may set to Vout equal to 229 volt, and Vi is known to be 230 volt. Then 229 times Xt plus Xc equal to 230 times Xc. That is, Xc equal to 230 minus 229 equal to 229 Xt. Substitute Xt at 2500 MHz equal to 1320 ohms, calculated in slide 2. Xc equal to 229 times 1320 equal to 302,280 ohms, equal to 0.3 megaohms. As we want Xc to be output at 50 Hz, Xc equal to 1 over 2 pi 50 C. C equal to 1 over 2 pi divided by 50 divided by 229 divided by 1320 equal to 1.053 times 10 to the power minus 8 farad. C is equal to 0.01 μF, equal to 0.01 times 10 to the power minus 6 times 10 to the power 9 divided by 10 to the power 9, equal to 0.01 times 10 to the power minus 6 plus 9 nanofarad, equal to 10 nanofarad. Source: capacitor 10 nanofarad slash 250 volt slash dash polyester capacitor. Donbert.ie. Now we come back to analyze the equations. Loop 1, 230 equal to I1 times J 1320 plus I1 minus I2 times minus 300,280. Equation 2. Loop 2, 0 equal to I2 minus I1 times minus 302,280 plus 229. Equation 3. Equation 2 plus equation 3. 230 equal to I1 times J 1320 plus 229. That is I1 equal to 1 over J 1320 equal to minus J 0.0008 equal to minus J 0.8 milliampere. Substitute I1 into 2. 230 equal to minus J 0.008 times J 1320 plus minus J 0.0008 times minus J 302,280 plus I2 times J 302,080. 230 equal to 1.056 minus 241.8242 plus J plus I2 times J 302,280. 470.7680 equal to I1 times J 302,200. That is I2 equal to 470.768 divided by 3202280 equal to minus J 0.0016 ampere equal to minus J 1.6 milliampere capacity. Future output power equal to I2 times VO equal to 0.0016 times 229 equal to 0.366 watt. This calculation indicated that the filter output may support a television set which require 0.27 watt operating consumption. Quantity 1. Part number capacitor C. Description: capacitor polyester 10 nanofarad 250 volt. Manufacturer Donbert Electronics. Source: Donbert Plasma enhanced. With the application of the CAS plasma technology, it may enhance the reception of RF in the antenna, and it may enhance the transfer of current through the McGrath coil in the low-pass filter. The antenna heatsink made of aluminum block when it has nano-coated aluminum oxide. The oxide can be a source of electrons by taking a view that each element has free electrons that are unbounded by chemical bonds in their outer electronic configuration shell. Nano-coating has lots of free electrons to absorb microsonic energy. In electronic configuration, we have 28-18-32 notation, or in another way, the SPDF orbitals. First shell 1s2, second shell 2s2, 2p6, third shell 3s2, 3p6, 3d10. The fourth shell 4s2, 4p6, 4d10, 4f14. The aluminum oxide, aluminum Al13, 283, equal to 0 free electrons, because 3 used in chemical bonds. Al2 equal to 0. Oxygen 826 equal to 4 free electrons, 2 used for chemical bonds. O3 equal to 12. Al2O3 equal to 12 free electrons. Nano-coating of aluminum antenna surface may be done by brushing with hydrogen peroxide. 2Al plus 3H2O2 to 2Al2O3 plus 6H2. The copper-clad base nano-coating may be brushed with water and sodium hydroxide. Cu plus 2NaOH plus H2O into CuO plus 2Na2O2 OH plus H2. Copper Cu28 2818-1 equal to 0 free electrons, 1 used in chemical bond. Oxygen 826 equal to 5 free electrons, 1 used in chemical bond. CuO equal to 5 free electrons, black in color. Note: caution with chemicals. Wear safety gloves and gloves when handling. Add small quantity sodium hydroxide at a time into large quantity water and mix well, then brush. Solder antenna lead wires to copper base before the nano coating. Transformer T2. The 12-volt AC to 230-volt AC step-up transformer may not be commonly available from the electrical hardware market. Normally, the primary winding 12-volt are to be on the underside, and the secondary winding on the top side of the transformer. One may find 230 to 12-volt step-down transformer and cannot be used in reverse. It has to be rewound. For research reference, T2 The step-up transformer winding as below. Primary coil N1 equal to 5 turns with 2.5 turns center tapping. AWG14 1.63 mm. Capacity 8.3 ampere. N2 secondary can be wound with diameter wire size AWG20 equal to 0.81 mm, 2 ampere capacity. Diameter of winding N2 equal to 1.5 inch equal to 38.1 mm. Radius equal to 19.05 mm. There is center tapping at 2.5 turns. Only half of the primary is operating at a time. N equal to 2.5 times 230 divided by 10.4 equal to 55 turns. Length equal to 2 pi times 0.01905 times 10 times 55 equal to 10 meters wire length. Center tap voltage 12 volt minus 1.6 volt equal to 10.4 volt times 0.5 ampere equal to 5.2 VA. Secondary equal to 5.2 VA divided by 230 equal to 0.0226 ampere. T2 output equal to 230 times 0.0226 ampere equal to 5.2 watt at 250 megahertz. Microsonic Plasma Energy Device. The complete circuit is synthesized as below. Microsonic Plasma Energy Device 5 watt. Parts required. Quantity. Part number. Description. Manufacturer. Source. 1 U90C-25NT-2011 Heatsink CPU cooler. Manufacturer AlphaNovaTech. Source www.alphanovatech.com. 12 1N4001 Dial 1A 1 volt 35 volt. Manufacturer Diodes Incorporated. Source alldatasheets.com. 2 860-160-672-006 capacitor 5.6 μF 50 volt. Bizhay. Source DG key. 2 UUD0J270 MCL1GS cap aluminum 27 μF 6.3 volt. Manufacturer Nichicon. Source DG key. 1 switch slide non-specific 1 non-specific resistor 47 megohm non-specific. Source dgkey.com. 1 non-specific resistor 41k ohm non-specific. dgkey.com. 1 WEZ 6.2B Zener dial 6 volt DC limit LZ equal to IC equal to 5 milliampere. Manufacturer Rome. Source alldatasheet.com. 2N2218. Transistor NPN. FT 250 MHz. Manufacturer ST Microelectronics. Source www.st.com. 1 T2 12 volt to 230 volt step-up transformer. Transformer 12 volt to 230 volt step-up. 12 volt primary with center tap 12 volt VA. Non-specific. Source unknown. 1 McGrath coil. Gravitational. 14 AWG 1.6 mm diameter. N equal to 81. Solenoid equal spacing. Turns. L equal to 0.8994 μh. Magnetical. 14 AWG 1.6 mm diameter. N equal to 81 solenoid equal spacing turns. L equal to 2.4983 μh. LT combined inductance 0.8290 μH. Manufacturer non-specific. Source unknown. 1. C. Capacitor. Polyester 10 nanofarad 25 250 volt. Dornbird Electronics. www.dornbird.ie. 1 AC receptacle. Receptacle 230 volt AC. Non-specific. 1 fuse. Fuse 0.5 ampere. 250 volt. Non-specific. Conclusion. As inspired by Mr. Maxwell Chikumbutsu's presentation, the Microsonic Energy Device (MSED) at 500 watt powered a television set. Findings from the video, The Low-Frequency Universe, presented by Dr. Mary Kemp, that on Earth ground it is zero opacity to radio frequencies between wavelengths 5 cm to 10 meters. And the sound of the Earth peaked at 9.5 kHz, coincide with the lower half of the audio frequency's bandwidth, 20 kHz. This frequency, f equal to 9.5 kHz, and the wavelength lambda equal to 3.61 cm may be the basis for microsonic energy. Photon energy at 9.5 kHz, E equal to h nu, and its zero-point energies, E average equal to n plus half h nu, where n equal to 0, 1, 2 may be small. The 3.61 cm to 5 cm wavelength may be of interest is that a small size antenna, such as a desktop computer CPU cooler heatsink, can receive the 3.61 cm to 5 cm wavelengths. Being trapped between the flaps may absorb this energy. The application of the CAS plasma technology using nano coating on aluminum and copper on the heatsink antenna augmented the free electrons unbounded by chemical bonds available from oxides, Al2O3, 16 free electrons, and CuO5, 3 electrons. A 9 cm square heatsink may have the capacity to absorb 2.5299 times 10 to the power 72 microsonic photon energy and convert the free electrons into usable current in the antenna circuit presented by Mr. Fresel. With 6 diodes and the combination of capacitors, 12-volt DC output may be attainable. The Alex-Chekhov demagnetizer circuit. After replacement of the transistors from KT815A, the IC max equal to 1.58 changed to 2N2218, IC max equal to 1 ampere. The 12-volt DC is converted to AC at transition frequency Ft equal to 250 MHz, and the T2 step-up transformer changed the 10.4 VAC into 230 volt AC at 250 MHz. The 250 MHz AC is filtered through the low-pass filter using McGrath coil and the component capacitor, expecting to give output at 230 volts, 50 Hz, 0.026 ampere, 5 watt. Caution: nano coating. Be cautious about handling chemicals. Wear safety gloves and gloves. Add small quantity of sodium hydroxide into larger quantity water, and not the other way around. Sodium hydroxide is known to be very reactive and produces heat in water. Wire size. The McGrath coil uses AWG14 diameter 1.6 mm wire size for 8.3 amp current capacity. To stay in shape for consistent inductance current flow through the component. Interconnections with the Armand's connector for lead wires and for transfer of plasma energy to avoid heating up of wires and components in the circuit. Screws tightening. Low wattage 25 watt soldering for electronic component interconnections and lead wire terminations to avoid sparking over arcing connections that may lead to the breakage of electronic components, insulations, heating up of wires. Check for short circuit before power on. Without low, RL equal to infinitive ohm. Open circuit on the AC outlet receptacle. The input terminals, brown wires to blue wires, may read 0.3 ohms as the secondary coil of T2 being measured by an ohmmeter. 0 ohm is short circuit. Somewhere in the circuit may be touching each other or a wire being shorted to the ground. Use transparent electrical box. After breadboard testing, the entire circuit is to be soldered in printed circuit board. The complete assembly to be installed in a transparent plastic box for RF to go through for fixation to avoid wires dangling around, vulnerable of disturbance to the circuit function. 12-volt DC, 230-volt AC in use. Labeling in the electrical box to alert users and maintenance personnel. Thanks for watching. This completes my presentation. This presentation is based on circuit analysis. I wish this presentation to be useful to the knowledge seekers, engineers, researchers, and students. Thank you, Mr. Maxwell Chicumbuso, for the knowledge on microsonic energy. Thank you, Dr. Mary Kapp, for the knowledge on the low-frequency universe. Thank you, Mr. Cash, for the knowledge on plasma technology. Thank you, Armin. Thank you, Thomas Mesa. Thank you, Alex Chekakov, for the demagnetizer circuit. Thank you, LG. Thank you, alldatasheets.com, dgkey.com, Donbert IE. Thank you, YouTube. Thank you, Wikipedia. Thank you, knowledge seekers. Have a good day. Peace to the world.